Hi, I'm Chris Adkin. I'm based in the UK. I work as a SQL Server Solutions Architect for Pure Storage. I've been working with SQL Server for the best part of 20 years in roles which have ranged from DBA to developer to architect. At this year's event, I will be presenting a 50-minute session on continuous integration with Azure DevOps, stateful containers, and parallelism. Hi, I'm Chris Adkin, and in this session I'm going to talk about Azure DevOps pipelines with parallelism and containers. A bit about myself: I'm a SQL Server Solutions Architect at Pure Storage. I've been using SQL Server for over 20 years. I've been heavily involved with the SQL Server 2019 early adopter programs, specifically around big data clusters. And off the back of this, I helped put together the Microsoft course you can find on GitHub entitled Big Data Clusters from Bare Metal to Kubernetes. So I'm based in the UK. I've spoken at a number of community SQL Server and data platform events around Europe, including SQL Bits. I gave a full day workshop at the SQL Bits event in Liverpool. The agenda for this session is as follows. So starting off with Container and Storage 101, followed by Azure DevOps Pipelines for SQL Server 101. We're then going to put the two things together to solve an interesting problem. And then finally, we'll wrap up, or I will wrap up with some useful resources. So, Docker containers. For the purpose of this session, I'm going to focus on the standalone Docker engine. So please do not confuse this for running a Docker container inside a container orchestration platform such as Kubernetes. The two are similar, but they are not the same. Okay, so if we use the default storage option, which is just simply to spin up a container and rely on whatever the local file system of the host where we're running the Docker engine runs, what that gives us. Let's go through what happens. Okay, so we'll start up a container, create some data, stop our container SQL1, remove it, and question: how long does the state created at time t1 last for? And the answer is that as soon as we get rid of our container, we lose any data associated with that. Okay. This might be absolutely fine, it might be absolutely what we want, but what if we want to reuse that data? What if we want to spin up another container that leverages that data? And this is where we use something called a Docker volume. So we can create this in its own command. We can either use the Docker volume create command, or we can create the volume in the same command line that we use to spin up our container. If we use Docker volume create, we want to give this the driver name of our storage plugin, a size, and a unique name. Then when we create our container, we use the -v switch to specify the name of the volume and where we want to mount that. So this is /var/ops/MSQL. We create some data in the container, we stop our container, we remove it, and then after T3 or T4 even, our data is still present. So the only way we can lose this data is if somebody comes along and they explicitly run a Docker volume RF command against our Docker volume. Okay, So moving on to CI pipelines, they consist of 4 basic elements irrespective of how our software is constructed, what languages, frameworks, tools it uses, where it runs. First off, we need to check out code from the source code management system. So I've got the GitHub icon here, but it could be vanilla Git, GitLab, Bitbucket, Subversion. We then want to build an artifact, which is essentially a posh name for something that we can deploy somewhere. So this could be an executable, a DLL, a jar file. It's going to be a DAC pack for the purpose of this session. We then deploy that to somewhere we can run a bunch of tests against. Okay, so we run our test. In an ideal world, they'll all pass. Because the world is often not ideal, the chances are that a test might fail. So what we want to do here is we want to get a developer to fix the change which broke the build. We want to run this all again and again, all being well in an ideal world. Our pipeline should run to completion and all the tests at the end should pass. Okay, so we can leverage containers within pipelines in one or two ways. So first off, we can leverage containers as agents, as the things which actually perform work in the pipeline, or we can leverage a container as a sidecar. So in other words, something which performs an auxiliary task. And in this case, we're going to use our sidecar to spin up the target that we're going to deploy to. So if we take our basic 4-step CI pipeline, we throw this into the mix, we get an additional step in between building the artifact and deploying the artifact. And pipelines are a strategic resource. As per this session at Dave Farley, author of a book on continuous delivery, which is generally regarded to be the Bible on the subject. So, as per a session that Dave delivered at Pipeline Conference 2018 in London, a pipeline is the only channel to production. All changes in production flow through your pipeline. If your pipeline breaks or goes slow, this impacts. The impact is enormous. So please focus in, zoom in on the go slow element. Okay, so if we're performing a number of integration tests against something that's stateful, again, I'm going to use SQL Server. This could be applied to any database or data platform, relational, NoSQL, whatever. The key thing is it's something that stores data. Okay, you can run your test in one or two ways. So first off, you can run your test sequentially, which is fine, but running something in a single threaded, single stream manner is inherently slow. What you therefore want to do is you want to run your test in parallel. Okay, if you do this against a single database, there's a problem with that. Your tests can get in each other's way and cause chaos. So what you ideally want to do is run each test against its own dedicated database. Okay, and this is what I'm going to largely cover off in the rest of the session. Okay, I'm also going to use pipeline as code because it promotes code reusability. It allows you to store your pipeline alongside your source code. Okay, and even though this is specific to Azure DevOps pipelines, it applies equally well to things like Jenkins, Travis CI, Circle CI, GitLab. I dare say even hit things like Tekton as well. Okay, and I'm going to cover what I would consider to be 5 advanced topics. So parallelism, containers as sidecars, templates, artifacts, and the merging of test results. Okay, our build environment is going to look like this. So I'm going to use Azure DevOps in the Azure Public Cloud. Alternatively, you could use Azure DevOps Server. Irrespective of what you do, you have to use build agents. These can be self-hosted, meaning you run them on your own infrastructure, or hosted, which means you run them on someone else's infrastructure, such as the Azure Public Cloud. I'm going to use build agents associated with two pools, a Windows pool, which contains all the tooling for building and deploying my artifact, my DAC pack, and also a Linux pool, which is going to be associated with an Ubuntu server, which I'm going to spin up my containers on. So let's take a look on a view of the world from the Azure DevOps portal. Okay, so this is our YAML pipeline as code. It comprises of 5 jobs. You don't worry about having to take this in line by line, because what I'm going to do is I'm going to break each of the 5 jobs down in detail. Okay, I'm going to run this. The purpose of this largely is to basically prove to you that this is real, that it's not what I'm going to show you isn't smoke and mirrors. Okay, so we want to start off with a clean environment, which means we've got no containers or Docker volumes lying around from previous runs. Okay, we're going to build our DAC pack. We're then going to spin up our 4 containerized SQL Server instance sidecars in parallel. Okay, so each one is going to have its own Docker volume, which is cloned from what I call a seed volume. Okay, so it's based on the TPCH database. Everything I'm going to do is very simple, because it's not the complexity of the test that's important. It's the principles behind how we've put this build pipeline together and how it behaves. Okay, so we're going to let each sidecar spin up, and then we're going to deploy the DAC pack to each one, and we're going to run a unique T-SQL-T test against each one. And as a bit of a spoiler, I've purposefully made sure that for one of the tests, the expected result does not match the actual result. So this is going to fail. Okay, I've engineered that. And then at the end, we're going to publish our test results, and we'll see a nice little dashboard, which allows us to drill into what's failed. Okay, so let's let that run. And you'll notice those blue circles with the white arrows swirling around. If you have more than one of those running at any one time, it means that you've got things running in parallel. Okay. And you can actually drill down into via the output for each step and task. You can see what each T-SQL-T unit test has resulted in. Okay, so entering the home straight. Okay, you can see the failure there, as I mentioned. Okay, and also what I've done is I've configured the last job to fail the pipeline if any test fails. Okay, so as promised, let's drill down into each job. Okay, so there's 5 jobs. You have to have at least 1 job per pipeline. A job is comprised of steps, and a step consists of 1 or more tasks. Okay, so this is executing against the master branch. We can have as a trigger a pull request. We clean up the environment by removing any old containers or volumes which might be lying around from previous executions of the pipeline. Okay, then we spin up our 4 sidecar containers in parallel. So notice the code I've highlighted in bold at the top: strategy and matrix. Okay, so I've got 4 labels for each sidecar container, and each container has a unique container name, external port, Docker volume name, and T-SQL-T test class. Okay, we then take each set of variables in our matrix. Okay, so there's 4 in total, and we run the code in the step section 4 times for each set. Okay, also note that I'm using a template. Okay, so a template is how you can factor out code that you want to reuse across pipelines. Okay, so my template is stored in line with my YAML code for my pipeline, and also my SQL Server Data Tools project. Alternatively, you can store it in its own dedicated repo. Okay, and because I'm passing in more than 1 parameter, I'm having to use the format command to substitute the parameters that I'm passing in for the placeholders in curly braces. Okay, and then finally you have to use the template task to invoke the code in your template. Okay, so I'm running up to 4 things in parallel, and because of that you have to set the maximum number of jobs to a default other than 1. Okay, I mentioned artifacts, and this is where the concept of artifacts first rears its head. What I'm doing is I'm creating an artifact called DACpack for my actual DACpack, and what this allows me to do is this allows me in other words, it provides the most elegant means of using artifacts later on throughout the rest of the pipeline. So what you do is, on one hand, you publish the artifact to create it in the first instance, okay, and then to actually reuse the artifact later on, you actually download the artifact. Hence, we've got this download build artifact task. Okay, so we've got parallelism here again. This time around, what we're doing is we're enabling CLR for each containerized SQL Server instance, because T-SQL-T uses this. Okay, we're running a unique test class for each containerized instance. Okay, and then what we're doing is we're publishing our results to an XML file, and we're ultimately in the next job. Okay, what we're going to do is we're going to use the published test results task to pull together the contents of each of those 4 XML files. Okay, we're going to merge those test results. Ergo, we have merged test results set to true, and we're going to hard code the pipeline to fail if we get a test that fails. So I mentioned I've got some useful resources for you. Here they are. So first off, if you're doing this on premises, go to the Docker store, then plugins, then storage. see what your vendor has for you. If you want to do this using Azure, you can use Azure Container Instances and file share volumes. All the code, so by all the code I mean the SQL Server Data Tools project and solution, the YAML pipeline as code, and then the actual template, that's all in the same GitHub repo. Okay, so you can fork that, just look at it, reuse it, copy and paste bits. One of the reasons I put this together is because despite the fact the YAML schema is very well documented in the final link, I couldn't actually find anything which provided like an end-to-end example which sort of tied it all together in a sort of a SQL Server context. Another takeaway I want you to go away with is that a best practice is that you should parameterize your pipelines. If you do that, you can specify the name of the Docker volume you pass in. So just think about that for a second. What this does is it gives you the ability to customize the pipeline dynamically in terms of the test data set you pass in. And I suspect it's probably not just me, but that seems like a really powerful thing to do. Okay, so I'm going to open up the session for questions. If you have any questions which pop into your heads after the session's open, please feel free to ping them over to me via either Twitter. So you've got my Twitter handle of ChrisAdkin8. Alternatively, you can email me. My email address is there. So any questions, I'll be absolutely delighted to try and answer them to the best of my ability.